Hello everybody, it's Dr. Cliff again, and I'm going to help you today with some cost volume analysis and specifically a break-even point. This example is going to take us a little bit because there's 2 or 3 problems that we're actually going to work, but we'll go ahead and get started. So first thing you'll notice over here in columns G and H is I have a few formulas, and those are formulas out of your textbook, or I often use Investopedia, which is like Wikipedia. It's a great little resource when you're looking for a formula or trying to find some information on some financial concept. So we'll get to those in a minute, but just keep in mind over here in column G and H are the formulas that we're going to use. So cost volume analysis, break-even point. This is an example of a cupcake operation. Some of you know my wife, Mrs. Dr. Cliff, and know that she's into baking and is always wanting to have some kind of a business that has to do with cooking. So this is her cupcake operation. So first thing that we need in a cost volume analysis is we need some data that has to do with cost and price that we sell our product for. So cupcake operation, obviously she's selling cupcakes and she sells them by the batch. A batch is 20 cupcakes. And what she sells those 20 cupcakes for, the price is $20. So they're little tiny cupcakes, $1 a piece. But then we've got some cost. And one of the first things we have to know when we're working with cost volume analysis is, are our costs fixed or are costs variable? So let's think for a second, what's a fixed cost? Fixed costs are costs that are the same every month, no matter how much volume, no matter how many cupcakes she were to sell. So she got a little building that she rents, and it's $2,500 a month. And obviously on rent, that doesn't change. If she makes 1 cupcake, it's $2,500 a month. And if she made 1,000 batches of cupcakes, it'd still be $2,500 a month. So that rent doesn't change with time. Property tax is the same way. Property tax is based on the value of the property, so it doesn't change when she makes more cupcakes. And then a manager salary, so we have a manager there, and that manager makes $7,000 a month. Again, doesn't matter how many batches of cupcakes we make, the manager is salaried. So first thing we need is a total fixed cost, and we remember that Excel's got a nice little sum function. So I can either use the equals SUM sum in parentheses, or I'll use the auto sum. Excel knows that you use sum an awful lot. So by using the auto sum, that tells me I've got $9,675 a month, no matter how much volume we do. Then we got to look at variable costs for making these cupcakes. So what do we have? We got the ingredients. So we're talking about flour and sugar and butter and milk, and there's $10 worth of ingredients in every batch. So these are just the opposite of the fixed costs. These are variable costs. In other words, if we don't make any batches of cupcakes, if we make no cupcakes, then we have no ingredient cost, so it'd be 0. If we make 1 batch of cupcakes, it's $10 worth of ingredients. If we make 2 batches of cupcakes, it doubles, it's $20. If we make 3 batches, it's $30 worth of ingredients. So these variable costs are variable depending on how many batches or how much volume you actually do. And it's linear, meaning if I make twice as many cupcakes, I have twice as much variable cost. So variable cost is the ingredients, $10 a batch, labor, $4 a batch, utilities to run the ovens and the mixers, all the electricity that goes on, $2 a batch. So total variable cost. Again, I'm going to do the same thing. I'm going to use that auto sum, and it tells me for every batch of cupcakes, I got $16 worth of variable cost. So within a given month, my costs are $9,675 for the fixed costs plus $16 times however many batches of cupcakes I make that month. And my revenue is just my price, what I sell them for, times however many batches of cupcakes I make that month. All right, so let's see what the first question is going to ask us here. Got them blacked out, but we'll uncover the first question. So the first question has to do with break-even point. How many batches must be sold to break even each month? So if we just think about it, we just look at it and don't worry about a formula for a second. Let's say a month went by and she only sold 1 batch of cupcakes. Or let's make it easier. Let's say she sold no cupcakes. So our revenue would be nothing. We would have $20 times 0. We didn't sell any cupcakes. Our variable cost would be 0 because we had $16 times no cupcakes, so that would be 0. But we still had the fixed cost $96.75, so we would lose $9,675 that month. So this question just asks, well, then how many batches do we actually have to make in order to break even, which means we cover all of our costs, no profit, but we cover all the costs that are involved. And let's see what this break-even formula tells us. It tells us the break-even point. So that, again, that's the quantity that we need to sell in order to cover all of our costs, where we have no profit, but we have no loss. So profit would be exactly 0. So break-even point is the F, the fixed cost, divided by the P, the price of the $20 of what we sell a batch for, minus V, the variable cost. And some of you might remember from accounting, price minus variable cost, you might call that a contribution margin. You should recognize all these formulas from accounting, but we'll go ahead and work them. Okay, so how many batches do we have to sell in order to break even each month? We're just going to use this formula. It's the fixed cost divided by the price minus the variable cost. So I'm going to say it's the fixed cost. Remember there was our fixed cost divided by our price, $20 a batch, minus our variable cost, $16 a batch. And so what does that tell us? It tells us that in order to cover all the cost and not lose anything each month, we would have to make 2,419 batches of cupcakes. And at that volume, or that quantity, all the costs are covered. There's no profit left over, so this isn't a great business, but at least we're not losing money. So that's an important point to remember, is that break-even point. Okay, let's go look at our next question. Let's see what else this problem wants us to do. So again, I'm going to unhide. And we see that our next question says, what profit would be made if we sold a certain number of batches, however many batches? We can kind of play with that. And let's see, again, we've got a formula. The profit at any particular volume is just the P, the price, the $20 a batch, minus the variable cost, 16. So there's our contribution margin again. There's our, we make $4 each time we make a batch, times our quantity, minus the fixed cost. So that's what our profit is. All right, and so we want to try a couple different numbers here. So let's see. We know from the previous problem that at 2,419 batches, our profit's going to be 0. So that's really, this problem is going to tell us the break-even point, but it's going to tell us profits at all kind of different volumes. So I'm going to just start off with 1,000. I want to see what happens if we make 1,000 batches. Maybe if we make 1,500, 2,000. Normally I would put 2,500 here, but I just want to see if the calculation above is correct. If I make 2,419 batches, I would expect this profit to be 0. So I'm going to kind of highlight that to tell me that's a special number. Then I'm going to just keep on. What if business gets good? What if we sell 3,000 batches or 3,500 batches? Okay, so we know the numbers that we want to check, but now we got to figure out what's the profit. So again, let's look at our formula. Profit is our price minus our variable cost times the quantity minus the fixed cost. So here's a case where we got to keep up with our absolute referencing, because there's some numbers up there like price and fixed cost that every time we want our fixed cost, we want that cell. We want what's in cell B10. And if we put the formula here and then we copy it down, if we don't do anything special, then what's going to happen is B10 is going to turn into B11, B12. So let's see what we need to do. We want our price minus our variable cost in parentheses. So I say I want my price, but again, remember, I don't want B5 when I copy this down to the next row. I don't want it to turn into B6. So I got to use that absolute referencing, that F4 button. So B5 minus my variable cost, and B16, same way. I don't want that to move. Let's go back up and make sure we're doing this right. We did our price minus our variable cost. We're going to multiply that times our quantity. So where's our quantity going to come from? Well, our quantity is right here. It's our volume in terms of batches. And I do want that to change. So when I copy this formula down, I don't want A26 when I copy it down this next row. I want A27. So I don't need to put the dollar signs in. I don't need absolute referencing for that term. And let's go look at our formula again. And then I need to subtract my fixed cost. And my fixed cost are here, but they're going to stay the same. So I do want the F4, the absolute referencing. Okay, that doesn't look very good. It says if I make 1,000, or if I sell 1,000 batches, then I lose $5,675 for the month. But that does kind of seem right, because this said I got to make 2,400 batches in order to break even to cover my cost. And let's see what this looks like if we copy this formula down. Whoops. Yeah, that looks right, because that tells me at 2,419 batches, I make $1. So there must be some rounding errors in there. That's my break-even point. I basically make no profit, but I cover all of my cost. And if I get up to 3,500 batches, then I'm making $4,325 in profit each month. Okay, let's see. We've got our data, and it might be nice to see this in terms of a graph. I mean, we can look in this table and see what's going on, but maybe if we graphed it, it might tell us something. So I'm going to go to Insert, and I'm going to choose a line graph up here. And Excel doesn't quite know what's going on. It's trying to graph the volume, so I don't want that blue line. That looks like the profit. Kind of looks like we're moving the right direction. I'm going to change this to a little formatting of this axis over here. I'm going to say that, because I like my volume, I like that to be down at the bottom. And I want my volume to be that horizontal axis. And now let's see what we've got. Yeah, this looks about right. So now it tells me if I produce 1,000 batches of cupcakes, then my profit over here is going to be negative 50. It's almost going to be a negative 6,000. I'm going to lose $6,000 for the month if all I do is produce 1,000 batches. And then we see our numbers start going up linearly. So as I produce 1,500 batches, I lose about $3,500. And somewhere right here around 2419, we cross the zero line. So there's our break-even point. It's whenever we go from losing money each month to making money each month. And we can see that that's right there around that 2419. Our line kind of flattens out because our volume, we didn't keep stepping up in $500 increments. So that graph tells us what this table tells us, that we got to produce 2,419 units, batches, in order to break even. Anything below that, we lose money. Anything above that, we make money. I'm going to clean this graph up just a little bit. I think we have seen what we need to see, but just so the graph maybe looks a little bit nicer, I'm going to get rid of this legend because I'm only graphing one thing. I really don't need a legend that says that's the profit, because the title tells me that's the profit. These numbers down here along the bottom, that's our volume in terms of batches. And this horizontal axis, is our profit in terms of dollars. And there we go. Graph looks pretty nice. So that tells us our profit at any given volume. Again, the great thing about Excel is somebody might come along and say, well, yeah, I think this business is really going to take off. Instead of just 3,500 batches, what if we did like 6,000 batches? So instead of getting our calculator out and a pencil and having to recalculate, I just put it in. I can say really quickly, all right, if we can sell 6,000 batches a month, $14,325. That'd be great. I might be able to retire. Okay, let's see what we got for our last problem. We'll uncover this. All right, so how many batches must be sold to make a certain dollar in profit? So this one is just the exact opposite from the problem that we just worked. In the problem we just worked, we said, if given a certain number of batches, how many dollars would we make? This one's going the opposite direction, saying, well, if I want to make a certain amount of profit, then how many batches do I need to have? So it's really this table worked in reverse. And we're going to look at a couple different numbers. I want to see, well, how many batches would I have to make? Not that I would want to lose $1,000, but if I felt like, hey, we can handle losing $1,000 a month, we could do that for a couple months until this business gets up on its feet, but we couldn't really afford to lose much more than $1,000 a month. So I want to know how many batches of cupcakes do we have to make in order to only lose $1,000 a month. Then I'm going to check that break-even point. I want to know how many batches do we have to make in order to cover our cost exactly. And we should know the answer. This, if everything works right, this has got to come up to something like 2419 batches. And then let's start looking at, well, what if times are better? What if we make 1,000? How many batches do we have to make and sell in order to make $1,000 worth of profit? Let's say 2,500 worth of profit. Oh, I said 25,000. 2,500 worth of profit. I don't want to get that extreme. And maybe $10,000 worth of profit. Okay, so we got us a little formula up here. Again, I went to the book, went to Investopedia, and it said, okay, the quantity required for a given profit is the profit plus the fixed cost divided by the price minus the variable cost. So we just got to get that formula put into Excel. So again, profit plus fixed divided by price minus variable. And again, we got to think about which ones are relative cost, or which ones are relative and which ones are absolute. So it says I want my profit. Well, there's my profit, and I want it to change. So I will not use absolute referencing there. And I want to add to that my fixed cost. But the fixed cost is always in that cell, so I don't want it to change. So I'm going to do my F4, put my dollar signs in there. And then it says divide by my price minus my variable. And those are always in the same point. So I'm going to use those absolute references. Find my variable cost. And this tells me that if all I want to do is lose $1,000 for the month, we've got to at least be able to sell 2,169 batches. So let's copy that formula down. And we can kind of check this number. Remember, that was the number we thought was, that was our break-even point. And sure enough, it's the 2419 that we found there, and it's the 2419 that we found there. So all that kind of matches up. So here's what that tells me. If my goal is to only lose $1,000 for the month, we need to produce 2169 batches. We need to sell 2169 batches. Break even, 2419. If we're looking for $1,000 a month profit out of this business, $26.69. If we're looking for $2,500 a month profit, then we've got to sell 3,044 batches. If we're trying to get $10,000 worth of profit, then we got to sell 4,919 batches. Here's why I like to do all of this in Excel. We created this model and everything looks good, but what happens if Mrs. Dr. Cliff comes and says, hey, I got bad news for you. The ingredients, the flour has gone up, and it's gone up by $1 per batch. So instead of this being $10 per batch, that's now $11 per batch. If I had done this by hand, then I'd have to do everything all over again. I'd have to recreate every single calculation. Okay, so since we changed this in Excel, we can change this to $11 instead of $10 per batch. And everything updates automatically. So now what happens? My break-even point goes to 3,225. Of course, this isn't highlighted anymore because that's not our break-even point. Our break-even point is 3,225. Okay, so let's see. At 3,000 I was losing money, at 6,000 I was making money, so I do know that the break-even point is somewhere in between those two, but this told me the break-even is supposed to be at 3,225, so let's see if that's right. If I put 3,225 in here for my volume in terms of batches, yep, I get $0 worth of profit, so that makes sense. All that kind of matches up, and same way down here, my profit and the volume required to make that profit, everything shifts a little bit now. Okay, so I hope that helped you out. There were quite a few different problems there for cost volume analysis. This is an important concept when you're trying to set up a supply chain business because it tells you how much volume you have to do in order to cover your cost and how much volume you have to do in order to make the profit that you're really shooting for. So I'm Dr. Cliff, and I hope that helped you out.